Today we are learning about prime and composite numbers and prime factorization. Let's start with a few definitions for prime and composite numbers. A factor is a number that is multiplied by another to make a product. A prime number is a number with exactly two factors, 1 and itself. A composite number is a number with more than two factors. Let's look at a few examples together. 3 is a prime number because it has two factors, 1 and itself. So we could say 1 times 3 equals 3. Nine is a composite number. Because it has three factors. It has more than two factors. The three factors are 1, 3, and 9. We can multiply these factors together to equal 9. So 1 times 9 equals 9, and 3 times 3 equals 9. Two is a prime number. Because it has two factors, 1 and itself. So we can multiply 1 times 2, and it equals 2. 2 is special because it is the only even prime number. The number 1 is a special case because it is neither prime nor composite. This is because it only has one factor. One. 0 is also a special case. It is not prime or composite because it cannot be listed as a product of primes. Anything times 0 is 0. Now let's look at some numbers and decide whether or not they are prime or composite. First, we'll look at 13. I need to think of all the factors that could be multiplied together to equal 13. The only ones I can think of are 1 and 13. So 1 times 13 equals 13. Because there are only two factors, This number is prime. Now let's look at the number 39. I know I can multiply 1 and 39 together to equal 39. I can also multiply 3 times 13 together to equal 39. So because there are more than 2 factors, there are 4 total factors for 39, it cannot be a prime number. If there's more than 2 factors, my number is composite. So 39 is a composite number. Last, let's look at the number 25. Again, I know I can multiply 1 times 25, and it equals 25. I can also multiply 5 times 5 to equal 25. So 5 is another factor. Because there are more than 2 factors for 25, this number is composite. Now that we've reviewed prime and composite numbers, let's learn about prime factorization. We know a number is prime when it only has 2 factors, 1 and itself. The prime factorization of a number is when we break a number down into a multiplication sentence of its prime numbers. When finding the prime factorization of a number, we will first start with the composite number. In this example, our composite number is 84. Next, we will break it apart using prime numbers until we cannot break it apart anymore. As we are breaking apart the number, we will circle all of the prime numbers. In the example to the left, we broke 84 down. We can multiply 2 times 42, and that equals 84. 2 is a prime number, so it is circled. 42 is a composite number, so again I have to break it down. 2 times 21 equals 42. Again, 2 is a prime number, so it is circled. 21 is a composite number because it has more than 2 factors. So when we break it down, 3 times 7 equals 21. Both 3 and 7 are prime, so they are circled. When there are only prime numbers left, it's time for us to write out the prime factorization by multiplying all of the circled prime numbers. You can see on the left, we multiplied all of the circled prime numbers together. We wrote them out in order from least to greatest. 2 times 2 times 3 times 7. Lastly, we can check our answer by multiplying out the prime factorization. If we were to multiply 2 times 2, we'd get 4. Multiply that by 3, we get 12. 12 times 7 is 84, so we know we're correct. Let's look at the prime factorization of 100. We can break down the composite number 100 by multiplying 10 times 10. 10 is still a composite number, so we break it down again. 2 times 5 and 2 times 5 equal 10. Now we are left with only prime numbers, so they are circled. Notice how, again, the prime numbers are written in order from least to greatest. Two times 2 times 5 times 5. If we were to multiply these numbers together, we can check our answer to see if we're correct. 2 times 2 is 4. 4 times 5 is 20. And 20 times the last 5 equals 100. So we know we wrote our prime factorization correctly. Just like there can be multiple ways to simplify a fraction, there can also be multiple ways to solve for prime factorization of a number. Let's look at an example together. We have the composite number 60. We break apart 60 on the left, we can multiply 6 times 10. Both 6 and 10 are still composite numbers. So if I'm looking at the 6, I can break it apart by multiplying 2 times 3. Looking at the 10, I can break it apart by multiplying 2 times 5. Now I am left with only prime numbers. If we look at the example on the right, we still have the composite number of 60. This time I could use different factors to break 60 apart. I could break it apart by multiplying 2 times 30. 2 is a prime number. But 30 is a composite number, so I need to break 30 apart even further. I can multiply 5 times 6, which equals 30. 6 is a composite number, so we can break it apart by multiplying 2 times 3. Now we're left with only prime numbers. There were multiple ways to solve for the prime factorization of 60. Notice how both times we ended up with the same prime numbers. Now let's write our prime numbers in order from least to greatest. Some are already written in for us. 2 times, there's another 2, times 3 times the 5. If we multiply these numbers together, it should equal 60. 2 times the 2 is 4. 4 times 3 is 12. And 12 times 5 equals 60. So we know we've reached the correct prime factorization. Let's practice solving for the prime factorization of numbers. It's important to remember to write your prime factorization in order from least to greatest. Let's fill in the missing numbers for each of the factor trees. The first number on the left is 18. This is a composite number that we need to break down. We can break it apart by multiplying 3 times 6. The 3 is a prime number, but the 6 is composite, so I need to break it down even further. So 6 can be broken down into 2 times 3. Both 2 and 3 are prime, so we can circle those. And now we are only left with prime numbers. Down below, the factors were already written out for us in order from least to greatest. We have 1, 2, then we multiply it by 2 3s. 2 times 3 times 3. If we multiply these numbers together, they should equal 18. 2 times 3 is 6, times the last 3 is 18. Now let's look at 64. If we break apart 64, we can multiply 8 times 8. Both 8 and the other 8 are composite numbers, so they need to be broken apart even further. We can multiply 2 times 4 and 2 times 4 to break apart 8. Both 2's are prime numbers, so we can circle those. Both 4's are composite, so we need to break those down even further. 4 can be broken down into 2 times 2. And 2 times 2. Now we are left with only prime numbers. I'm going to circle my 2's. And write them down below. We have 6 2's. Some are already written down below for us. 2 times 2 times 2 times 2 times 2 times 2. This is the prime factorization of 64. Next, let's look at 88. 88 can be broken down into 4 times 22. Both the 4 and 22 are composite, so they need to be broken down even further. 4 can be broken down into 2 times 2. 22 can be broken down into 2 times 11. Now I'm left with only prime numbers. I'm going to circle my prime numbers and write them down below in order from least to greatest. The 3 2's are already written down below, so I'm going to add 11. The prime factorization of 88 is 2 times 2 times 2 times 11. Let's look at 4 more examples together. 250 can be broken down into 25 times 10. Both 25 and 10 are composite numbers, so they need to be broken down even further. 25 can be broken down into 5 times 5. 10 can be broken down into 2 times 5. Now I'm left with only prime numbers. Circle the prime numbers and we'll write them down below in order from least to greatest. I'll write the 2 first, and then multiply it by the 3 5s. So the prime factorization of 250 is 2 times 5 times 5 times 5. Next, let's look at the prime factorization of 42. 42 can be broken down into 6 times 7. 7 is a prime number, so we can circle it. 6, however, is a composite number, so it needs to be broken down even further. 6 can be broken down into 2 times 3. Both the 2 and the 3 are prime numbers, so I can circle them. Now I am left with only prime numbers, so we can write them down below in order from least to greatest. 2 times 3 times 7. The prime factorization of 42 is 2 times 3 times 7. Now let's look at the prime factorization of 300. 300 can be broken down into 30 times 10. Both 30 and 10 are composite numbers, so they need to be broken down even further. 30 can be broken down into 6 times 5. 10 can be broken down into 2 times 5. Next, I'll circle my prime numbers. Six is a composite number, so it needs to be broken down even further. 6 can be broken down into 2 times 3. And now I'm left with only prime numbers. I'll circle my prime numbers, and then I'll write them down below in order from least to greatest. I see 2 2s, a 3, and 2 5s. The prime factorization of 300 is 2 times 2 times 3 times 5 times 5. Last, let's look at the prime factorization of 88. 88 can be broken down into 8 times 11. 11 is a prime number, so I'm going to circle it. 8 is a composite number, so it needs to be broken down. 8 can be broken down into 4 times 2. 2 is a prime number, so I can circle it. If we break down 4, we can multiply 2 times 2. Now I'm left with only prime numbers, so I'm going to circle them and then write them down below in order from least to greatest. 2 times 2 times 2 times 11. The prime factorization of 88 is 2 times 2 times 2 times 11. Now we will work on some guided practice together, and then you will complete some independent practice on your own.